Hello. So why? This is for me, one of the most important things you need to understand, because it affects your motivation to engage with the maths. So for instance, why would we be wanting to look at data tables and data analysis for applied social science? One of the reasons has to be, of course, it helps us answer questions. Yeah, we're going to set ourselves questions throughout our courses here and our studies here. And we're not doing maths for the sake of doing maths. We're doing maths to help us answer the hypothesis we set. For instance, my background is economics. So as an economist, I would be looking at things about, well, what might be there's the hypothesis, the increase in interest rates will lead to a decrease in house prices. And I'd use the statistics and my mathematical modelling to help me answer that based on my theoretical understandings. So really the why bit is the first and probably the most important point of the maths, because it will affect how motivated you are to engage with it, and therefore how much time and effort you're willing to put in to overcome any problems or issues you have. The why bit, of course, comes from your lecturers. So I strongly recommend you to engage with your course team to really understand why you need to do this, why you're doing it, and what will be the outcomes and the products, and what will you do it in the future. So in terms of looking at data analysis, and here we just look at data analysis in the form of a table. We've got some statistics here. So we've got some data here. So what sort of things would I be looking at? I've got 5 questions, and the next slide as well, I've got another 5 questions. So some of the strategies I might use are as follows. Firstly, before I give a quick scan of the question, so I read the questions as they are here. So in 1996, what percentage of UK households had a mobile phone is question 1. Question 2 is what percentage of UK households had a computer in 2000 and 2001. And then question 3, I've got, do more UK households have a satellite receiver than a home computer? And question 4 is, which of the 5 items is most commonly owned by UK households? And question 5 is it true to say that by 2002-03, twice as many households had computers as in 96-97? Now, reading the questions gives me the context that I'm going to be looking at, and now I'm just going to look at the data, and the sort of things that it's telling me. So firstly, I can see this is about the UK. Secondly, I've got dates here, so this is over time. This is a piece of longitudinal information. So I go from 96 all the way to 2003. Here I've got a set of items. I can see mobile phones, I can see satellite receivers, CD players, home computers, and internet access. And the last piece of information I have is these have been percentages. So these must be percentages of households in the UK which have a mobile phone. So if I now look at question 1, it starts to make a bit more sense. And the reason for doing this as well is if we can understand the context that this data sits in, it's going to be much easier to do the analysis and come up with questions. So in 1996, I find 96. What percentage of UK households had a mobile phone? I find mobile phones. So the answer would be 17%. Question 2. What percentage of UK households had a computer in 2000-2001? So I find 2000-2001, which is there. I then find computers, which is there. I then work out that 44% had a computer in 2000. Now, question 3, do more UK households have a satellite receiver than a home computer? Now here I'm going to pick the last date. There's 2 ways of doing it. I can pick the last date or just compare them over the general time, but I'm going to do the last date. So in 2002, do more UK households have a satellite receiver than a home computer? Find satellite receiver, which is 46. Find home computer, which is 55. So do they have more satellite receivers than home computers? The answer is no. They only have 46% of a satellite, but 55% have a home computer. Right. So and then question 4, which of the 5 items is most commonly owned by UK households? Now again, I'm going to pick the last date. So 2002 and 3. And what this means is commonly owned is, well, which one's got the largest number? Which number percentage of households own more of these? So I can look at that. 70. So mobile phones is 70. That's bigger than satellites. CD players is 83. That's bigger. It's 83 is the leader at the moment, and that's bigger than home computer, bigger than internet. So I would therefore simply say CD player. And then, is it true to say that in this date, twice as many households had computers as they did in that date? Okay, so I'm going to talk about computers. So this is going to be this column here, home computers. And I'm going to talk about this date here where it's 55, and 1996-97, which is 27 there. So what I'm saying then is this number 55 twice the size of that number? And if I do a bit of maths, 27 times 2 is, no, actually I can make it simpler. 7 plus 7 is 14, carry on, that's 54. So it's 54. So if they were twice as large, we can see it's bigger than twice. Yeah, it's more greater than twice as many. So the answer here would be yes. Okay, so that's the first set of 5. Now we've got some more questions. Okay, we've got question 6 is it true to say that home access to the internet was over 4 times greater in 2002 than 4 years earlier? Question 7, so I'm doing the same strategy. I can see I'm reading the questions to give me a feeling of each one before the overall ones, before I tackle them individually, and then I'm going to look at my table again. So it's the biggest surge in numbers. So this is quite interesting because I've got to think, what does a surge mean? How can I represent a surge in the data? Is it true to say that UK house ownership of phones quadrupled? So that's just looking at phone ownership and see how quadrupled is times by 4. So I'm happy there over a 6-year period. Did ownership of the mobile phones rise steadily from year to year? And it's given it roughly the same amount. So it's helped me understand what steadily is. So a surge is going to be a big increase, isn't it? And when did UK household ownership of phones overtake satellite receivers? So what date did this percentage of households with a phone be bigger than the percentage of households with a satellite receiver? Right. So home access to the internet. So I'm looking at, again, I'm in percentages. Home access to the internet. 2002 is this figure. And I want to go 4 years earlier. So I go 1, 2, 3, 4. So back to this figure. Is it true to say that it's 4 times greater? Yes, because 10 times 4 is 40. 45 is bigger than 40, therefore, yeah. When was the biggest surge in UK ownership of internet access? Now, a surge is a big increase, I've decided. So I'm looking for what's the difference between this number and this number, the 2 years. So there's no difference there, so that's 0. Actually, I'm going to change the colour because it might be easier to see. That's 0. 0 to 10, that's an increase of plus 10. 10 to 19 is an increase of plus 9. 19 to 33 is an increase of 14. 33 to 40 is an increase of 7. 40 to 40 is an increase of there. So when was the biggest surge, and is when was the biggest number increase? And that was between 1999 and 2001. Brilliant. So that's that one. And is it true to say UK household ownership of mobile phones quadrupled? So let's look at mobile phones. And we're looking at 96. And quadruple is times by 4. And we've got to go up to 6 years. So that's 1, 2, 3, 4, 5, 6. So if 17 times 4. So firstly, I've got to work out how big what would the number be, the percentage be if I quadrupled it. So 4 sevens are 28. 4 times 10 is 40. So that gives me 68. So then is the number in 2002, 2003 bigger than 68? If it is, then it has quadrupled. And it is, it's 70. So the answer there would be yes. Now, did ownership of mobile phones rise steadily year from year? So again, we're looking at the change. Well, that's +4. So we go back to mobile phones. That's +4 to there. That's +6. That's a plus 4, 7, 17. That's +3. That's plus 18. That's +5. Okay, so they're the differences between the year to see if I've got this steady growth. And we can see that if it was steady, they'd all be very, very similar, and they're not steady. So, because you go from a large one of 17, 18 to the smallest of 4. So the answer there will be no. So when did UK household ownership of mobile phones overtake satellite receivers? So basically we've got to find the when did this figure here be bigger than this figure here. So that's at the moment satellite's bigger, satellite's bigger, satellite's bigger just. This is when this becomes bigger than the satellite receivers. So the answer is there. Cool. And that gives us some ideas then about how we can look at table data for our data analysis. Something that also springs to mind though, what we should be looking or thinking about when we're looking at data is how accurate it is and the source. So something here that I would question in terms of the quality of the data set if I was to use it in any of my analysis is it's all very dated. Yeah, 96 to 2002, 2003, but we are in 2014, so it's very dated. How useful that's going to be outside of a historical study, I'm not quite sure. And secondly, the source. I don't know where this information comes from, so can I trust it? Would be the next one. Thank you. It's important when we're thinking about using applying maths in our studies is to the question of why. And the reason we want to know why is we're not doing it for the love of maths. We're doing it because we're applying it, or it's helping us achieve a goal. And the why bit will help motivate you into engaging with the more tricky bit of understanding the maths and going through the process of learning how to do it, developing strategies that work. So it's really important when you think about the maths and the support we give you, is you've talked and listened to your course teams who've helped motivate and inspire you to why completing or being able to successfully complete a drug calculation is really important for you and for your future career. Yeah. And that will hopefully motivate you to put the time and effort into doing the maths. Right, I'm just going to go through some examples here, and these have come from previous papers, so it will give us a feeling of what we need to do and what you need to do to make it all to help it work it all out. Okay. So these are legitimate, authentic examples for drug calculations on a level 4 paper. So let's just look at the question and think what we've got. And that's the thing, is to read the question slowly and to start to pick information out from the question. So Mrs. Ramsden, so females prescribed this. And they would prescribe this amount, 500 milligrams, and they would prescribe it twice daily. You have got tablets in a box who've got that amount of this drug in it. Yeah. And you want to know how many tablets you have to give in one day. So how many tablets are you going to have to prescribe in one day? Okay. So there's different ways of doing this. One strategy, of course, would be to say, well, if they need 500 milligrams and we've got tablets in 125 milligrams, the first thing I'm really pleased about is the units, milligrams and milligrams. I don't have to do any changing or conversion of units, which is really common in drug calculations, so that's actually to make life a lot easier for me. Now for me to approach this, what I'm going to do is work out that if they need 500, yeah, and they need that twice daily, I need 500 milligrams, but I have a tablet of 125 milligrams, then how many tablets do I need to give them to get up to 500? So basically that's working out what is 500 divided by 125, if I could write. And that would be, of course, 125, 250, 375, 500. So it's 4. So there's four 125s into 500. In other words, what that means to me in English is it will take 4 tablets of 125 milligrams to give the patient the 500 that they need. And that's in one dose. They need it twice daily. So I would then go, so how many tablets they need? They need 4 tablets in one dose. They need 2 doses a day. So that's 4 times 2 is 8. So the answer here is 8 tablets. Hi, this is the second question, or typical question around drug prescriptions. And here we're looking at one where we're going to be looking again, breaking the same strategy as before. Yeah, we've got a lady here prescribed this drug, and they need this amount, and they need it daily. Yeah. Then they said that the drug actually comes in 5 millimeters. I assume this is in suspensions, but in that 5 millimeters you get 20 milligrams, and they need 40 milligrams a day. Yeah. So how many milliliters will you need to give a 5-day course? Rightio. So this is then saying, well, again, it's the strategies we can adopt is different ways of doing. But firstly, let's say that if there's 20 milligrams in 5 milliliters, what would I need for 40 milligrams? I would need, well, that's twice the size, 20 to 40. So what's twice? 2 times 5 is 10. I would need 10 milliliters to give me 40 milligrams. And that would be for 1 day. Now we know it's a 5-day course. So I've got to times this by 5. Yeah, so over 5 days it would be 5 times the 10 milliliters equals 50 milliliters. And that is for a 5-day course. Brilliant. So that is our answer. Yeah. So Tracy will have to have 50 milliliters to give her 40 milligrams over 5 days. The answer is there. Again, the same strategy as before. I slowed it down. I tried to understand what was important in the question. The 40. Well, what do we mean by here? This is 20 milligrams in 5 milliliters. Well, I can assume that's something. And then in suspension, it's in liquid form. So how many this liquid milliliters will I need for a 5-day course? The third example is from Fergus for this particular drug here. Now, Fergus has prescribed this drug, and he could prescribe this amount. Needs 0.6 milligrams. You, however, in the back of the van, have got a pack of tablets of the drug, which contain, and each tablet contains 600 micrograms. So not milligrams, they're micrograms. They're different units. And this is where this question becomes just a weeny teeny bit more complicated. We've got to know then how many tablets you'll give Fergus for 1 dose. So how many tablets do you have of this? Do you have to give Fergus to get his 0.6 milligrams? So the bit we've got to work out to start with is that a microgram, an mcg, a microgram, is you get 1,000 micrograms equals 1 milligram. So a microgram is much, much smaller than a milligram. Yeah. And now then I've got to work out, well, get them in the same units is the next step. If I can get them in the same unit, I can do the comparison. So let's convert the tablets. We'll just convert the tablets into that. That'll be the easiest way. So what is then, if I want to convert this into milligrams, I know the tablet's got 600 divided by 1,000 will give me what it is in milligrams. Okay, because I know 1,000 micrograms equals 1 milligram. So I'm going to do, say, 600 divided by 1,000 will give me that. If I do that, and this is the way I do it, so divide by 10, go there, divide by 100, go there, divide by 1,000, go there. So that's going to give me 0.6. So in each tablet, it has 600 micrograms, or which is equivalent or the same as 0.6 milligrams. So in fact, this question now has become really simple, because each tablet already contains 0.6 milligrams, which is the amount that Fergus needs. So Fergus would have, in one dose, he would have one. I just have to give him one tablet. Now if it was different, for instance, if Fergus needed 0.9 milligrams, say, what would I do then? Well, I would give him 1.5 tablets. Because that would be 0.6, that's one tablet's got 0.6 in, and then I need 0.3 to give me up to a 0.9, yeah? And that's half a tablet. Alternatively, if he needed 1.2 milligrams, I would give him 2 tablets. Yeah. So this question really nicely falls down to doing the conversion of what is a relationship between micrograms and milligrams.